Our learning objective is to provide you with the information you need to take your initial steps into your data analytics journey by exploring the basics on that matter. If you don't know what exactly data analytics is and how organizations are using it to leverage more efficient solutions, then this course is for you. My name is Rafael Lopez, but you can call me Ref. I am from Brazil and I work with AWS training and certification for 6 years. I created this course where I will teach you the knowledge needed to create a basic data analytics solution out of log files. The plan to achieve that is to understand the basics of some of the most popular AWS services involved on doing data analysis. So I will talk about Amazon S3, Amazon Athena, and Amazon QuickSight. I will also talk about descriptive, diagnostic, predictive, and prescriptive data analysis types, mostly focusing on the descriptive analysis, which focus on exploring what happened. Ready to get started? I am. So come with me to start your journey about learning data analytics in the AWS cloud. Hello! If you are here, you probably have an interest in data analytics, and that's great. So let me start sharing with you the value proposition of what data analytics is. The first thing we need to think about when talking about data analytics is how to use the collected data to produce information that would be useful for future business needs. Those are called insights. Sometimes, this journey of generating insights out of data can be big and complex, involving the use of machine learning, or sometimes it can be quick and simple if the dataset is ready and you just want to perform descriptive data analysis. That being said, data analytics is the science of handling data collected by computer systems in order to generate the insights that will improve decision-making with facts based on data. Nowadays, data analytics is widely used for e-commerce and social media, but the knowledge can and should be applied into information security, logistics, factory operations, Internet of Things, and much more. There are 4 main types of data analytics, which in order of complexity are listed as descriptive, diagnostic, predictive, and prescriptive. Let me talk a bit regarding each one of those. I will spend a bit more time on the descriptive analytics because in this introductory course, this is what I will be mostly covering. Descriptive analysis is a data analysis type that is mainly used to give you information regarding what happened. It is intended to allow you to use data collected by a system in order to help you identify what was wrong, what could be improved, or which metric is not reporting as it should. As this type of data analysis is widely used to summarize large datasets in order to describe outcomes to stakeholders, think about descriptive analysis as something that just reports what's going on and nothing more. The most relevant metrics informed by those systems are mostly known as KPIs, or Key Performance Indicators. Identifying what happened can be extremely important for some market verticals and sometimes are enough to satisfy the needs for further investigation into an issue. Let me give you an example on how descriptive data analysis can be useful in terms of identifying the correct KPIs to keep stakeholders aware on taking data-driven decisions to fix potential issues. Imagine an e-commerce website where you collect metrics regarding the time required for a payment to be processed. In this website, you are using an external payment gateway to complete the purchases. So every time a customer buys something in your website, the customer is redirected to that payment gateway and you have a confirmation that the customer had paid when he or she did so. A relevant set of KPIs for doing an effective descriptive analysis in this case could be metrics regarding the time required to complete the transaction, number of completed transactions, and number of cancelled transactions. Now, if you see a spike on both number of cancelled transactions and time required to complete the transaction, that may be a good indicator that those transactions are being cancelled because they are taking too long. It may be a good indicator that those KPIs might be related to each other, which could help systems administrators and business owners to start troubleshooting a potential issue that may be impacting on sales. The very same concept applies within the time to complete the transactions. If you have something that drills down into that metric by separating each step within the transaction time, you would have even more granular information to pinpoint the right place to solve the issue. The last thing you want is to be informed about system malfunctions via social media feeds or customer inputs. In this case, monitoring is key, and we used a very simple set of metrics in order to start troubleshooting a business-related issue. In a nutshell, descriptive data analysis is a concept that informs you what's going on. You can also do descriptive data analysis if you have data regarding user activity, social media feeds, Internet of Things, or system security logs. As I said, the use case can vary a lot, but one thing is for sure. Once you have the knowledge on how to perform descriptive data analysis, you can and should use that same knowledge to work with different datasets. Great! Now you have a solid fundamentals regarding what is descriptive data analysis. What about the other three? Well, remember in our example that you had the metrics regarding the transaction time and number of failed transactions? In that case, you were the one responsible for having the insights, for having the idea to correlate those two metrics together in order to identify the issue. The system did not connect them together and gave you a consolidated or a projected metric called probability of issue with the payment gateway. It is very common nowadays to have hundreds or even thousands of those metrics in systems, and diagnostic analysis helps by going over the scope of just informing, but diagnosing by further investigating and correlating those KPIs in order to give you suggestions on where the issue could potentially be. I like to refer to diagnostic analysis as a set of actions a system can do to help stakeholders understanding why something happened. The word you need to remember here is why. Our third type of data analysis is the predictive analysis. Predictive data analysis involves more complexity because, as the name suggests, it predicts what is likely to happen in the future based on data from the past, or based on doing a data crossover between multiple datasets and sources. In a nutshell, it kinda tries to predict the future based on actions from the past. The use of neural networks, regression, and decision trees are very common on diagnostic analysis, and we will be covering that in another course. Now, last but not least, prescriptive analysis, which is basically a sum of all the previous. Prescriptive analysis can go ahead and suggest stakeholders what are the most data-driven decisions that needs to be taken based on past events and outcomes. Prescriptive analysis highly relies on machine learning strategies in order to find patterns and their corresponding remediations by looking and crossing large datasets. Regardless of the type you decide to learn and apply, data analysis exists at the intersection of using information technology, statistics, and domain knowledge, like social media, business, or industry verticals. In this course, we will be focusing on how to use AWS services to perform descriptive analysis about what's going on with an AWS account by using security logs. If you got interested and want to dive deeper, check out the course notes for this video. Now that you understood the different types of data analysis, let's continue the journey by exploring some more examples on where data analysis is present in your life right now. Now that you know the difference between the different types of data analysis, let me show you some examples on how data analytics is very likely to be present right now in your life, both as a consumer and perhaps professionally. Data analytics is widely present in many verticals today, such as gaming, social media feeds, e-commerce, online stores, website statistics, also known as click streaming, recommendation engines, Internet of Things or IoT, log processing, and much more. Let me give you a couple of examples on where data analytics is valuable in some of those scenarios, so you grasp what is the exact purpose of data analytics in these contexts. Let's say you like to play computer games, like me. Who doesn't, right? So if you like to play games either in your phone, your computer, or in a game console, you may be familiar with the checkbox you may need to check before start play. That checkbox usually says something like send anonymous data statistics for game developers to improve gaming experience or such. What this does is basically allowing collecting information regarding the way you play the game in order to detect potential crashes, design failures, and other data. It is clear in this case that real-life data such as you playing a game is being transformed into information that helps developers to circumvent potential issues and enhance the gaming experience. That is exactly why data analytics exists and why it is so relevant for the modern world. You may ask, why is this a thing nowadays? I've been playing games since childhood, and that was not the case. Games were sold on cartridges, we used it to buy and play it, right? Well, yes, but if you think with me, those games were not that complex as the games we have today. And that's what I want to conclude. Analytics helps people develop insights, and those insights help them to deal with complex problem solving. No matter if it is regarding gaming, stock market, real estate data, traffic information, fashion, computer systems, web server, or security logs, data analytics help to provide answers to complex scenarios. With storage prices going down day after day, companies often collect data that may currently not have a use for. However, if a question arises tomorrow, the answer can be in the data they had previously collected. The world nowadays is becoming more complex than it was 10 years ago, and having the help of computer systems is instrumental for two main reasons: scalability and data-driven decision-making. Another major part of data analysis is log analytics. Let me dig a little deeper into this one because that is where I will mainly focus during this course, specifically regarding security logs. When we talk about log analysis, we're usually talking about the information produced by computer systems based on events. That event can be an HTTP request made to a web page, user login information, API calls, or any other type of requests. API is the acronym for Application Programming Interface, which is basically a computing interface which defines interactions between multiple software intermediaries. It defines the kinds of calls or requests that can be made, how to make them, the data formats that should be used, the conventions to follow, etc. And for the data analytics standpoint, it is very common to log all those activities somewhere. A classic example of data analytics is using web server logs to extract insights about visitors in a website. Let's say every request made to an HTTP server is logged into files in a file system. Those are mostly called access logs. If you have one new line added to the access log per every visit in your website, you can say that the number of lines in this log is equivalent to the number of requests that was served by the web server. If you just have one server and a small website with a couple of visits per minute, you can use some basic tools like text editors to parse those files and extract what you're looking for. But if you want to do something slightly more useful than just summing up lines in a log file, the usage of a data analysis tool is key. We encourage using data analysis tools everywhere, but we need professional ones that handles scale when we want to do log aggregation and visualization. Imagine you have tens of web servers attending thousands of users per second. You can estimate that each log file on each server will be filled up pretty quick. So you need to have all that data concentrated somewhere. In addition, you may need to have a way to visualize that data in a line chart, which could easily help you identifying spikes, also called deviations or outliers. Another big use of data analysis nowadays is data security. If you have systems producing security logs in a way you can quickly get into in order to extract analytics, you are in clear advantage if you need to pinpoint when a request was made, by whom, from when, from where, and what was the system's response to that request. If you reach into the level of doing predictive analysis on top of this data, you can even reach a state where you automatically block bad requests to computer systems before they occur, or creating a self-healing architecture that starts building a failover environment when a current environment is presenting degradation. That can be achieved with the help of infrastructure automation tools in the cloud. There is an AWS service called AWS CloudTrail, which logs API activity made to an AWS account, and another AWS service called Amazon S3, which is a storage service. Let me briefly talk about them. This is what CloudTrail stores every time you or someone logs into your AWS account by using the AWS Management Console. That is stored in Amazon S3 and contains information such as who made the request, from which IP address, what was the request for, what was the answer to that request, and some other useful compliance information that can quickly turn into evidence if needed. Because of that nature, CloudTrail is a service that enables infrastructure governance, operational auditing, and risk auditing for your AWS account. But if you need to dig into CloudTrail tax data every time, it may be something hard to achieve. So learning data analytics helps a lot to unleash what you can do with all this compliance data. If you had data visualization tools on information produced by CloudTrail, you can have security dashboards containing graphics and alerts of unusual activities. If you suddenly start seeing logs of login failures activities, it may be because someone is trying to log into your AWS account or because you changed the password and forgot it. I usually say that data security analytics is not good only for compliance reports, but also very useful for troubleshooting. If you apply that concept to firewall packets, networking activity, load balancer and server logs, and other kind of infrastructure topics, you can easily identify outliers and turn yourself into a quick problem solver. For the sake of simplicity and introduction to the subject, in this course I'll be talking about getting insights out of CloudTrail data. So I'll revisit CloudTrail again and build an analytics solution out of it. But always think about what else could you be using data analytics for and how it helps you on getting stronger insights about what's going on, no matter if it is regarding security, product improvement, better customer's experience, or any other part of the data analysis spectrum. Since the sky is the limit, in the next video I will be talking about why doing all this in the cloud gives you some serious advantage and how it helps on enabling data analytics everywhere, anytime, for everyone. You may already know that the cloud is more flexible, scalable, secure, distributed, and resilient. But I want to give a more data-related approach in terms of why cloud computing is relevant for data analytics. In this section, I will explain why the cloud is the best way to perform data analytics nowadays and why it has been solid for operating big data workloads. So let's get started. Before we start talking about cloud, allow me to go back in time, maybe a decade, and tell you a brief story. After going back in time, it will be natural for you to understand why everybody loves doing data analytics in the cloud. Ready for the journey? Get your beverage of choice and buckle up. Years ago, the most common approach for companies to have compute infrastructure, big data included, was to buy servers and install them into data centers. This is usually called a colocation, or colo. The thing is, servers utilized for data operations are not cheap, because they need lots of storage, consume lots of electricity, and requires careful maintenance regarding the data durability. Hence, entire dedicated infrastructure teams, and trust me, I've been one of those infrastructure analysts working with data centers. It is expensive and overwhelming. With that scenario, only big companies were able to work with big data, and consequently, data analytics was not popular. It was very common for those servers to have a RAID storage controller that replicates data across the disks, increasing the cost and maintenance care even more. In the early 2000s, big data operations were closely related to the underlying hardware, such as mainframes and server clusters. Although this was extremely profitable for the ones selling hardware, it was expensive and not flexible for the consumers. Then, something fantastic started to happen, and the name of this fantastic thing is Apache Hadoop. Mostly, what Hadoop does is replacing all that fancy hardware by software installed in the operating systems. Yeah, that's right. With the help of Hadoop and computing frameworks, data could be distributed and replicated across multiple servers by using distributed systems and eliminating the need of those expensive data replication hardware to start working with big data. All you needed was efficient network equipment, and the data were synchronized over the network to other servers. By embracing failures instead of trying to avoid them, Hadoop helped reducing hardware complexity, and when you reduce hardware complexity, you reduce cost. And by reducing cost, you start to democratize big data because smaller companies could start leveraging it as well. Welcome to the big data boom. I brought up Hadoop originally because Hadoop is the most popular open source big data ecosystem. There are others, and what I want to highlight here is the concept and not specific frameworks or vendors. The thing is, by baselining hardware to a basic level and applying all big data concepts to software, such as data replication, we can start thinking about running big data operations on providers that are capable to provide virtual machines with storage and a network card attached. We can start thinking about using the cloud to build entire data lakes, data warehousings, and data analytics solutions. Since then, cloud computing has emerged as an attractive alternative because it is exactly what it does. You can get virtual machines, install the software that will handle the data replication, distributed file systems, and entire big data ecosystems, and be happy without having to spend lots of money in hardware. The advantage is that cloud does not stop there. Many cloud providers, such as Amazon Web Services, started to see that customers were spinning up virtual machines to install big data tools and frameworks, and then based on that, Amazon started to create offerings with everything already installed, configured, and ready to use. That's why you have AWS services such as Amazon EMR, Amazon S3, Amazon RDS, Amazon Athena, and many others. Those are what we call managed services. All those are AWS services that operate in the data scope. In a later lesson, I will talk more about some services we will need to build our basic data analytics solution. Another big advantage of running data analytics in the cloud is the ability to stop paying for infrastructure resources when you don't need them anymore. This is very common in the data analytics because due to the nature of big data operations, you may need to run reports once in a while, and you can easily do that in the cloud by spinning up server or services, using them, getting the report you need, saving that, and turning off everything. In addition, you can temporarily spin more servers to speed up your jobs and turn off when you're done. And since you mostly pay per time and resource needed, 10 servers running for 1 hour tends to have the same price of 1 server running for 10 hours. Basically, with the cloud, you are having access to hardware without having to concern with all the burden involved on doing data center operations. It is like the best of both worlds. Stay with me to learn more about AWS services I will use towards my descriptive data analysis solution using Amazon S3, CloudTrail, Amazon Athena, and QuickSight. In this lesson, I will be talking about the basics on Amazon S3, Amazon Athena, and Amazon QuickSight, because those are the 3 services our data analytics solution will be built on. So before I start talking about the solution itself, I want to quickly introduce you to what those services do. S3 means Simple Storage Service, or SSS, or S3. As the name suggests, it is the most simple and popular AWS service for storage. We all love S3 for many reasons, being the 3 most relevant ones. First, it replicates data by default across multiple facilities, providing solid data durability, which means that chances of data being lost is reduced a lot. Second, it charges per usage, so the pricing goes exactly according to your needs. No more, no less than what you need. And third, it is deeply integrated with other AWS services. So if you have any other AWS service that needs to store data somewhere, S3 is the very first candidate to be integrated with that service. For example, if you are using AWS Elastic Load Balancer or ELBs to balance traffic to your website front end, ELB can save the access logs into an S3 bucket. You've seen me saying S3 bucket. In the S3 nomenclature, buckets are the basic storage units that you put your data into. There is some basic vocabulary, which I can quickly explain. S3 is the service, buckets are the logical storage unit, objects are the data you add into a bucket. A bucket policy is the permission mechanism applied to a bucket, which defines who can and who cannot interact with the data inside it. In addition, S3 allows you to configure a storage class on the object level, also known as storage temperature, such as more or less accessed. That changes the price you pay per gigabyte stored, and you can save some money by moving less frequently accessed objects to a colder storage class. One bucket can have multiple objects, and the configuration of storage classes are on the object level. So you don't need to create multiple buckets or move objects around if you want different storage classes in your buckets. I put more information regarding storage classes in the course notes. Don't forget to take a look. What you need to know in order to build our analytics solution for this course is just that S3 is a secure and private place to store your data with redundancy and high availability. S3 is really simple. You create a bucket, add files to it, and read files from it. In S3 verbiage, those files are called objects, but I may call them files along this course just for simplicity. Now, let's say you have a CSV file, or comma-separated values. You may already be familiar with that file format, but imagine you want to import that file into a system in order to perform SQL or SQL queries against and extract insights. Imagine you have one, or better, thousands of files like this one you were seeing. This file contains information about taxi rides in New York City. It is a CSV file containing information regarding every ride, where each line represents a ride. I got this file from the AWS datasets page. You can get more information from the AWS datasets by reading the course notes. If you want to do a SQL query based on the information of this file, such as select average of the cost of the taxi rides during the month of January, you can do a SQL query. And if you want to do that with SQL, you basically have two options. Option 1, create a relational database server, such as MySQL or SQL Server, import that data into a SQL table, and perform the query regularly. Which, although could do the job, it wouldn't scale very well, and there is a better way of doing it, which is option 2. So option 2, import this data into Amazon S3 and use Amazon Athena to make that query without the need of creating database servers and having Amazon Athena performing the processing and scalability under the hood. That's right. Amazon Athena gives you the ability of doing SQL queries on top of files stored in S3, with no databases to configure, no servers to manage, and no database engine configurations to be done. That is what we call a serverless solution because there are no servers involved. You just create an Amazon Athena table, point that table to the bucket location, and you are ready to query against it. It is pretty simple and allow you to have an effective data processing tool out of the box. Athena also provides high availability by default and don't store your data. It just makes the queries. The best thing is that the data is primarily stored in Amazon S3 and not in Athena tables themselves, allowing you to centralize all your data into S3, which we already know it's highly durable. Well, now that you have a way to store files and query them, a missing component for a complete data analytics solution is a way to visualize the results of those Athena queries. Because Athena would give you text as the query result. But let's say you want to have a pie chart. Introducing Amazon QuickSight. Amazon QuickSight is a service that provides you dashboards and other ways to visualize and analyze your data. Let's say that you do an Athena query that results of a sum of the number of taxi rides per month. If you want that plotted in a pie chart, Amazon QuickSight does it. Do you want that plotted in a graph chart to follow up month by month? Done. QuickSight can also do that. What about day by day? Simple. Just ask QuickSight to perform a different Amazon Athena query grouping by day instead of month. You can actually do that by clicking around in QuickSight's web interface, as you will see in the demo I'm going to do in the next video. Those services are all integrated with each other and are the basic construction for many data analytics solutions: S3 to store, Athena to process, and QuickSight to visualize. Since they are all AWS services, the integration between them is seamlessly done, being very easy to start and to work with. I hope you are getting excited as much as I am about creating a simple data analytics solution. Ready to proceed? My idea is to explore AWS CloudTrail data that gets added automatically to S3, then dive deeper on Amazon QuickSight in order to create some cool visualizations. Let's do it. This demo will show you how you can visualize CloudTrail data in Amazon QuickSight in order to start building helpful security dashboards. I will start configuring CloudTrail from scratch. CloudTrail is actually enabled by default in every single AWS account, but you will see where the configurations on CloudTrail are made in case you have an AWS account with CloudTrail disabled. After enabling CloudTrail, I will add a secondary user into my AWS account. I will call that user Nicholas, and then I will log in as that user and do some activity simulating a user doing API calls, where one of those API calls will be accidentally turning off a web server that was being used in production. Then I will log out with the user I created and log in again as my administrator user. Then I will use CloudTrail data to discover what happened when the server was turned off, who turned off that web server, and also discover what other API calls were made by that same user, by that Nicholas user, right? Because that user could have been compromised. Usually the first thing that happens when accounts are compromised are people trying to change the password or API keys or trying to disable CloudTrail, right? We will see that on CloudTrail because CloudTrail logs both accepted and rejected API calls. Luckily, Nicholas won't be allowed to disable CloudTrail and either change his own password or do nothing with AWS IAM or Identity Access Management. So let's get started. So this is an AWS account that I just created for this demo. It has nothing in this account. I created this account 5 minutes ago. And I'm logged in this account as the user admin, as you can see here on the upper right corner, okay? First thing that I would like to do is go into CloudTrail to make sure that CloudTrail is enabled. So if you click here in services, it will show you all the AWS services, and there's more than 100. So because in this demo, we will be mostly working with Athena, CloudTrail, IAM, EC2, QuickSight, and S3, I added those as favorites. So if you click on this star that will pop up when you mouse over through the service name, you can add the specific service into this favorite bar here. So for example, if I want to work with Amazon Managed Blockchain, if I want to work with that a lot, a tip that I give you is put that on the favorites, and then you won't need to search for Amazon Managed Blockchain all the time in the service list. So let's go to CloudTrail. First service that I would like to show you, and we are in Virginia region, CloudTrail in Virginia region, and I already have a trail here, but just to make sure, I will create another one. So you can create multiple trails in CloudTrail because once you create a trail, you can choose an S3 bucket to log all the activity from that account into that bucket. And sometimes you may want to create in a bucket that belongs to a different AWS account. So it is very common for governance and compliance, specifically for companies that use multiple AWS accounts, it is very common to have multiple accounts logging the CloudTrail to the same bucket in a centralized account, right? So I can use an existing S3 bucket if I already had created an S3 bucket before to host all the files that I'm going to use for CloudTrail here, but CloudTrail gives me the option of creating a brand new, an empty S3 bucket for logging. I'm going to call this trail name default, and I'm going to give this name. It's a name that is suggested, and it puts a random hash because the bucket names, they must be globally unique. I can use encryption on this bucket. I won't enable encryption just to simplify things. And here are the options you can specify to configure and enable CloudTrail in an account. After I choose, I click next. And then it asks me, what do I want to log in that bucket? The more things I choose here, the more files will be created in the bucket, the more granular the information will be, right? So I am marking management events, which will capture management operations performed on the AWS resources, such as start an instance or delete an instance. An instance is a virtual machine, or create a bucket, delete a bucket, right? Create a database, things like that. So data events, they will actually log resource operations performed within a resource. In other words, if there is an existing resource like a bucket and someone deletes that bucket, or there is a specific virtual machine and someone changes the security configuration of that virtual machine, then this will also be logged. And insights is interesting. This is new in CloudTrail. CloudTrail already does a little bit of, it's not prescriptive analysis, but it identifies unusual activity. So it stores in the same bucket under a different folder, under a different prefix, events that are related to your account that are unusual. And this is interesting because CloudTrail can already have the ability of identify outliers in the data that is collecting and put that in the bucket for you. So I'm going to mark all of them. And here is where I choose what I want to do when for CloudTrail to store those events. I want to store them in an S3 bucket. And CloudTrail Insights, additional charges apply because it's doing some sort of machine learning for me under the hood. I have that enabled. And then next, I review everything, create trail. So this is the trail that I just created, and it will be logged in this specific S3 bucket. Pretty simple. If I go to S3, I will see that bucket, and then CloudTrail will start adding files into that bucket, right? So this is the bucket I just created, and you notice that you can create multiple trails as well, right? So I can create one trail that will log everything in a bucket in my account, and another trail that will create everything that happens in my account to another AWS account. And as I said, this multi-account logging strategy is very instrumental when you have multiple accounts, because there are some companies that want to separate their environments. Production, development, QA, dev, test, or there are the necessity of creating one account per developer. You can have the developers having their own account, but all the logging can be centralized in a bucket that belongs to a separate security AWS account, right? So this is how CloudTrail stores the data in S3. It stores in the folder or prefix AWS logs, then it adds your account ID. This is my account ID. And if you had multiple accounts providing data to the same bucket, CloudTrail would separate the prefixes per account. So you have the report per account. Then this is the CloudTrail Insights. There is nothing so far because I did not give time for CloudTrail to populate and maybe detect unusual activity. And here in CloudTrail, it separates per region and then timestamp, where it comes the year, the month, the day, and then there will be files corresponding to the API calls I am doing. Those files, they were just generated. And they were just generated including the information from S3 browsing that I am doing here in the console. So all this activity that I'm doing here in the console, like clicking around and navigating through the buckets, it is also logged by CloudTrail because I am doing API calls of the type list objects and list buckets, right? And another thing, when I am clicking around on the AWS Management Console, I am doing a bunch of API calls. So if I go here on EC2, which is the virtual machines, Elastic Compute Cloud EC2, and just by loading this screen, there are lots of API calls that were made. Because how do I know that I have 3 volumes? How do I know that I have 2 security groups? How do I know that I have 3 running instances? There were API calls made to the EC2 service to describe instances, to describe security groups, to describe volumes, right? So CloudTrail is logging each one of those operations separately in a JSON file. If I click here in instances, I'm going to see that I have 3 servers, 3 instances running, right? So let's say those are the web servers, right? Let's say those instances here, they are web servers. Okay, so when I am clicking around on the AWS Management Console, CloudTrail is already logging everything. If I go to IAM, which is the Identity Access Management, IAM, I am going to create a new user. And I'm going to click in Add User. And I'm going to call this user Nicholas. I will provide AWS Management Console access to Nicholas with a custom password, which I choose here. And I will disable the user must create a new password at the next signing. Next, I'm going to assign some permissions to Nicholas, and I'm going to do that by clicking here in Attach Existing Policies directly. And I'm going to give Nicholas EC2 full access and S3 full access, for example. So regarding those security policies, there is lots of things to be considered before giving someone administrator policies that, like I'm doing here, giving Nicholas EC2 everything and S3 everything. There is a whole security white paper, there are whole security best practices regarding those policies. But for the sake of the demo of having a separate user doing API calls and logging and seeing those log activity through Athena and QuickSight, I'm going to be giving Nicholas S3 and EC2 admin policy, and then review and create the user. So now I am going to copy this URL here, which is the URL this user will need to sign in. Copy. Then I'm going to close. And now I have two users, mine and Nicholas. Now let's log out and log in as Nicholas. Go to the URL. Ref analytics demo, Nicholas, and then the password. Sign in. Now I am logged as another user Nicholas, as you can see here on the upper right corner. And this user Nicholas is going to the EC2 console. And this user is also click here in instances. And let's say this user is going to instance state stop. And then, oh no, it turned off my web server. So potentially my website is now offline, right? So this user, that API call could have been intentionally, or it could have been inadvertently, right? So Nicholas' password may had an issue, and then he let his computer logged in, or something bad may have happened. There are also lots of security measurements you can take to prevent that from happening, right? And it is recommended to go after those policies. So now Nicholas is also going here on services, S3, and right now Nicholas is doing an API call called list buckets. And then, because Nicholas is authorized, Nicholas can see the buckets. Now Nicholas will go on CloudTrail because Nicholas wants to disable CloudTrail, right? To do nasty things in the account. This operation is not available because Nicholas does not have permissions to access this resource. Because when we created the user, we did not add permissions from Nicholas, for Nicholas to manage CloudTrail. And this is, for the security standpoint, this is extremely important. You should not give users permission to disable CloudTrail, right? And you should implement mechanisms for if someone disable CloudTrail, re-enable CloudTrail automatically, right? So Nicholas can do nothing with CloudTrail. Nicholas cannot see what are the trails, the event history, the dashboards, everything Nicholas clicks here. You can see that we can't find a match. Sorry, it will not happen. You're not authorized to do that. Now, another thing that Nicholas may try to do is to go to IAM to change his own password. And again, IAM is not authorized, right? So it fails on getting account summary, listing account aliases, and all the operations. So if Nicholas click here in users, you need permissions. You cannot see the users in this account. You cannot see the roles. You cannot see the policies. You cannot see the groups, right? So because our web server had been stopped, people are calling and people are complaining because the website is down. And then what we're going to do is actually log out as Nicholas, and I'm going to log back in as admin, as the initial user. Admin and my password. And now what I am going to do is actually go to S3 and go to my CloudTrail bucket. I want to see what was done in my account because CloudTrail logged all that activity. So I want to discover when that instance was stopped, who stopped that instance, what time, right? And from where that the IP address, that instance was stopped. So I'm going to click in AWS CloudTrail logs, AWS logs, my account ID, CloudTrail, US East 1, which is the Virginia region, year, month, day, and then I have a bunch of compressed text files, right? Because this is what CloudTrail stores. Compressed text files. If you take one of those files and you open one of those files by clicking here in Object Actions, Open, this is what you will see. And I don't need to go that beyond to tell you that this is not an end-to-end data analytics solutions, right? Because it's hard to find information in all those compressed text log files here. Right? If something weird happens to your AWS account, you would be on an urgency to discover what happened. And navigating through all those data when you need an insight, it may be complicated. So there is a better way to do it. And what we are going to do right now is configure Amazon Athena to query those data with SQL or SQL. So what we are going to do now is go to CloudTrail, because the easiest way to create the Amazon Athena table to work with CloudTrail data is actually through CloudTrail. So click here in Event History, and there is an option here called Create Athena Table. So you choose the bucket that you will want that Athena table to point to, and when you do that, it creates the Athena table setting that bucket as the table location. Remember when I said that the data is not stored in Athena? The data is still in S3. And you can see that the data is still in S3 because the Athena table will point to the S3 bucket, right? And these are all the fields of that file. So this file here is a JSON file that contains the curly braces and the brackets and everything. And it contains records, and then it breaks down because the format is always the same. And AWS already knows what is the format that CloudTrail pushes to S3. So it already creates the table mapping to that specific file, to that specific JSON, right? I just specify where are my CloudTrail logs, which sets the location here, and then I can click in Create Table. Now what this option is doing is creating an Amazon Athena table. And if I go to Athena, which is right here, or right here, right, you will see that there is an Amazon Athena table created, which is the table CloudTrail logs, AWS CloudTrail logs, and then this ID here. First thing that I should do when I go to Amazon Athena for the first time is to configure a bucket, an S3 bucket, that will be configured for Athena to store the query results. You will be doing queries here in Athena, and those queries may take 5 minutes, 10 minutes, half an hour to execute. It all depends on the data set you are querying against. And you don't want to keep waiting to see the query output on your AWS Management Console. Or you may have a solution that automatically integrates with Athena that does the queries under the hood for you. The thing is, Athena saves all the query results into, guess where? Amazon S3. Remember when I said that services provide integration with Amazon S3 to store the data they need in S3? So a bucket was already automatically created for us, and we can select that bucket, we can elect that bucket as the query results, as the Athena query results. So when we do an Athena query, Athena will store the query result in that bucket. We can encrypt those query results if we want, but for now, we're just going to choose that bucket and hit save. So here you see that you have a window where you can input, let me close this, where you can input things such as a query. And we can do a query like this one that I have here. So this query will select everything from a table, and we can copy the table name from here and paste the table name here, where event source equals ec2.amazonaws.com and request parameters like, and here we can copy paste the instance ID. So we can quickly go back to EC2, and it is important to open that in a new tab because I don't want to lose my text here. Then get the instances that are stopped, and I'm going to copy one of those instance IDs here, right? And then I'm going back to Athena, and I'm going to paste the instance ID. So what this is doing, and I'm ignoring the response elements equals that are not null. I only want response elements that were executed. In other words, I only want API calls that were satisfied. Because someone stopped that instance, that was an API call that got a satisfied request because the user was authorized. And I want to discover what CloudTrail gets for me in ec2.amazonaws.com as the event source, and request parameters containing that specific instance ID. Okay, so I am going to execute that by clicking on Run Query. Now, what Athena is actually doing, Athena is going on all that compressed text data, and you can see that this is way more friendly than having to parse, right, the information and having to look up the information in all this data. And This is just one of the files. You may have hundreds, thousands, or tens of thousands of compressed text files on S3. And what Athena did is, hey, I discovered something. I discovered that this specific user identity, and it is bringing me all the columns, event time, event source, event name, AWS region, because I did a select star. So I can see that something on console.ec2.aws, amazonaws.com was made for this instance ID, right? And the most important, I can see that this specific user made that call. All right. So having this user making that call is already an indicator that we are going to find out more information. So there is another query that I can do, which is select everything from this table, but now I want to filter for where user agent like console or everything containing console and user identity dot username like Nicholas, right? And this will give me every single API call that this user tried to do, right? If you already have CloudTrail running for a long time, you can also specify a date range here. It's SQL, it's SQL on top of compressed files on S3. That's basically what Athena is doing. So let me just double check user agent like console, because I know it was a console action because that user does not have programmatic access, and user identity dot username like Nicholas. All right, let's run this query and let's see what Athena brings to me. There are a bunch of calls, a bunch of API calls that were made by that specific IAM user, right? And here you can see what are the event name. Describe security groups, describe instance status, describe instances. So you can see what were all the activity made by Nicholas in the AWS Management Console, okay? So let's find a way to visualize that in QuickSight, because this information at that stage, I already know that what this user tried to do, but I would like to know more information, and I would like to know on a form of a charts, right? So for example, this is the most interesting one, access denied, and you know that CloudTrail also logs the events that were rejected, the events that the user tried to do, and the events that the user had not authorization of doing. And that's important because mostly based on that information, our prescriptive analysis, if we decide to build one, could see that and see, this user tried to change the password and this user tried to disable CloudTrail. It is very likely that this account is compromised, right? Or sometimes, oh no, this user just turned off the servers and inadvertently, let's take some security measurements to prevent these users on terminating instances in the future. So let's get this data that Amazon Athena gave me and let's plot that in charts in QuickSight. So for that, I will go to Amazon QuickSight by going on Services, QuickSight. And because I just created this AWS account is not registered in QuickSight yet. So I will hit Sign Up for QuickSight. Then here I have the option of subscribing for Amazon QuickSight Standard or Amazon QuickSight Enterprise. And this is the first thing that I would like to tell you if you were following this demo with your AWS account. After using QuickSight, you can go and delete the QuickSight dashboards and unsubscribe from QuickSight to avoid incurring costs in your AWS account. For now, I will choose the standard because what I want to do with QuickSight is pretty basic. And the main difference between standard and enterprise is the single sign-on with Active Directory. So you can do federation to have users that are logged in your Microsoft Active Directory to your Amazon QuickSight and other more granular things. It also gives you an additional of Spice per month. Spice is a processing layer. It's some sort of like a cache that QuickSight can do to accelerate the queries. But in this case, I will be asking QuickSight to be doing all the queries directly in my Amazon Athena. So I'm going to hit continue. I'm going to give that QuickSight a unique account name, which I'm going to call Ref Analytics Demo QuickSight. And I am going to give access to Amazon S3, and I am going to give access to the CloudTrail bucket and Amazon Athena, right? So next I'm going to hit finish. Oh, I need to provide a valid email. Let me put my email here. Just put an email, finish. Now it is creating my QuickSight account. That may take a little while to bake, maybe 1 or 2 minutes, and I'm going to use that time to review what we did so far. We enabled CloudTrail. We created a secondary user called Nicholas. We logged in as that user. We made a bunch of API calls, including turning off a functioning website. We logged back as the user admin. We went after the CloudTrail data, and we saw that it was pretty complex to navigate through all the CloudTrail data on the form that CloudTrail puts in the bucket. And we created an Amazon Athena query to do a select statement, a SQL select statement on top of that data and get the information back to us. Now we are in our QuickSight because we are going to create a data visualization on top of that response. So the first thing, I click in Go to QuickSight's dashboard. And QuickSight, for the first run, it populates a few samples for you, such as just a sample for you to play with business review analysis, people overview analysis, just to give you some working data to change the charts. So this is a sample of a QuickSight dashboard, right? So you could have this dashboard in full screen on your office, right? Or you could have your sales representatives, your security analysts, your social media analysts look into this data. And this data is actually populated regarding one of the QuickSight data sources. So in order to create a new QuickSight data source, we go here on Datasets, and then we click in New Dataset. When we click in New Dataset, those are all the possible integrations that you can have with Amazon QuickSight. You can integrate Adobe Analytics, you can integrate GitHub, Snowflake, Twitter, Amazon Aurora, which is a relational database, Amazon Elasticsearch Service, Spark, which is a Hadoop general purpose framework that you can have running on top of a Hadoop cluster that runs on AWS or somewhere else. You put Spark authentication and credentials here. In our case, we want to have QuickSight go into Athena. So I'm going to click here in Athena, and I'm going to give that data source a name, Athena1, and create data source. After I create the data source, I can click here on the table that I want to visualize, right? And then it will, if I click in select, I want to directly query my data, I can hit visualize. So as is, I am pointing QuickSight to my CloudTrail data. And the next thing that I want to do is click in here, admin, manage QuickSight, security and permissions, add or remove. And I also want QuickSight to be able to go on S3 to interact with the data that is in the CloudTrail bucket. So I want to hit here, S3, and I want to give access to the corresponding buckets to QuickSight, right? And now QuickSight is able to go to Athena to execute the queries, and also in S3 to read the data. Update. And when I go back to my data visualization by clicking here on the QuickSight logo, CloudTrail, I will already have, if I click here in event name, for example, QuickSight is doing an Athena query that queries S3 and gets that information for me and plots. So I can see that if I do a graph, a bar, according to events that happens in my AWS account, and remember that I am still not filtering by the user Nicholas. I'm just getting every single API call that is happening in my AWS account. And the reason why put object has way more here is because when CloudTrail adds things to S3, it is doing a put object operation, right? So if you can also apply some filters here and exclude the CloudTrail activity itself, right? Because it is impacting on the put object, because I just enabled CloudTrail. And for now, CloudTrail is doing way more work than everything else in my account because I just have CloudTrail logging things. So now let's see if I can create a custom report based on what I saw here, based on what I saw in terms of what were the specific API calls that Nicholas did on the console, right? The specific API calls that Nicholas did in the console. So I'm going back to CloudTrail, and I'm going back here, clicking on the logo, datasets, and I am going to create a new dataset, also pointing to Athena. And this dataset will already be filtered by only the requests made by Nicholas on the console. So I'm gonna name this Athena2, create data source, and I'm going to hit the button, use custom SQL. I am going to paste my custom SQL and call it Nicholas activity, confirm query. Oh, actually, of course, I have to replace the table name. So I'm actually going to get this very same query that I did here and put it here. That's why I got that exception. Confirm query. Now I want to directly query my data, visualize, and now in this specific QuickSight visualization, I will only be visualizing the events that were made by Nicholas, right? So if I click here in user agent, for example, I will see that it is doing a count by user agent, and those API calls were made to the EC2 console, and all those other API calls were done from console.amazonaws.com. Now, if I click here in user identity, or actually better, if I click here in, there is a error code, I can see that this user made API calls that got some access denied, 25 of them, and some other API calls that are 56 API calls that were access granted. And if I click here, I can easily transform that into a pie chart. So this is just an example on how you can get information that is in S3 that is queried by Athena and visualized in QuickSight. In this case, we use the CloudTrail dataset. I can rename this null to access granted API calls, and I can change this color as well. So access denied is red and access granted is green. So I can see that this user made 25 access denied API calls in the AWS Management Console and 56 access granted API calls in the AWS Management Console. So this gives you an idea, because the state that I want you to be thinking right now is security dashboards that can be used elsewhere, right? So there are AWS documentation pages with lots of recommended queries and recommended insights you can extract out of CloudTrail data. And that's it. You can resize this, you can make this bigger, smaller, you can add multiple visualizations in the same dashboard as well, right? So you can add another visual here, you can drag and drop, you can resize to put them side by side, and then in this one, you can do by event time. And remember that this dataset is already pre-filtered as Nicholas, right? Because it is working on the dataset that is already pre-filtered by Nicholas. And you can see line charts, you can see pie charts, you can see donut charts. QuickSight is a data visualization tool that accepts those data sources here. So when you click in new dataset, if you can query information using those services here, you can have a way of visualizing them in QuickSight. The demo gave you a good overall idea on how embracing analytics helps with navigating through data. We moved from seeing compressed files on S3 to query them with Amazon Athena, then engaged QuickSight to create some quick visualizations. In the demo, we could see the request was made by the user Nicholas. We could also see the IP address that the request came from, the timestamp, and other things that were logged by CloudTrail. We could also see all other API activity made by that user. So if that was a compromised account, we could have all the API trail left behind. I have one caveat and one solution for you now. The caveat is, CloudTrail already adds data into S3 in a friendly way to be consumed by Amazon Athena. Although we used a service integration and built a graph with minimal data modification, some datasets may need to be refined with the use of data processing tools. Some AWS services that can do that data transformation are Amazon EMR, Glue, AWS Lambda, or even code running on top of EC2 instances, depending on the dataset size and complexity. Actually, you can even use your computer to prepare the data before querying. I strongly encourage that you continue your journey across studying data processing and data transformation, because that plays big part on your journey as a data scientist. Now, my suggestion is, if you want to practice on your own, watching the demo again and experimenting on your own AWS account can also be a good idea. And remember, you don't need to limit QuickSight and data visualization tools to CloudTrail data only. The sky is the limit, and I hope this demo made you excited enough to experiment doing your own queries with your own datasets. In the demo, you could see how easy it is to build descriptive analysis in order to identify what was done, no matter if the data is infrastructure logging, e-commerce websites, social media feeds, IoT, or any other. The tools are basically the same, and I strongly suggest deeply exploring the AWS services involved in order to craft individual solutions for your needs. Remember the 4 types of data analytics: descriptive, diagnostic, predictive, and prescriptive. Although we realized that having charts about what is going on with your cloud infrastructure is a good thing, those are initial steps for developing a more mature cloud governance mindset. So speaking about the other types, let's talk a bit more about the predictive analysis, which is the one that tends to discover what is likely to happen in the future. Although that looks like a Back to the Future kind of thing, it is real and totally doable nowadays. It is very likely that you will need machine learning and neural networks for achieving that. That's because you will need to work with your dataset by aggregating data and mixing some processing power into that recipe. Although that sounds complicated, there are AWS managed services such as Amazon SageMaker, Amazon Lookout, AWS Cost Anomaly Detection, and other services that had already made the machine learning undifferentiated heavy lifting for you. You were right. There is no need to have a PhD in mathematics in order to do those things nowadays. That's right, Amazon Web Services has democratized the access to machine learning for everyone. Machine learning, or ML for short, would be able to analyze and predict when a bad API call is performed based on the activity history of that specific API call over time, which may include other aspects. If you have that level of monitoring, you are in advantage regarding infrastructure security because you can track and automatically respond to account modifications right before they happen, or before something bad happens, reinforcing security guardrails and AWS resources with a self-healing infrastructure. When you have predictive and prescriptive analysis working together, the next step is reducing false positives to have more precise automatic decision making. Let me give you one example. One of the things that CloudTrail logs is logging activity on the AWS Management Console. If you have a solution that detects if a user is repeatedly trying to log in the console with logging failures, the solution can flag that as a compromised account, especially if that user never had that type of failure in the past. And that is where I want to focus, on the especially if that user never had that type of failure in the past. Because if a user keeps changing and forgetting passwords all the time, would that be considered an outlier? When looking for anomalies, it is important to consider the patterns and the interactions with other entities or systems as well. For example, if a user is constantly trying to log in the console and keeps forgetting the passwords all the time, it may be more challenging for the predictive analysis algorithm to detect that as a red flag. In this case, other variables should be considered in order to qualify for potential deviations, which can be login time, IP addresses, browser agents, etc. There are many factors that influence on how systems behave with each other and how people interact with systems. Those variables can go from something regarding the own system to something totally non-obvious, like user feelings, keyboard issues on the other side, weather, and other variables. Yes, weather. You heard it right. Correlation causality is a very interesting topic, and there are lots of interesting books and resources around it. And overall, there is a big race in machine learning to reduce false positives, which can only be made by aggregating the largest amount of information you can collect and process all together with algorithms. Some of those things can be quickly evaluated by simple if statements in source code, but sometimes it requires cross-analyzing information across multiple computer systems. That is where the complexity comes from. That is why it is very common to use GPU processing and fast storage mechanisms for machine learning-based data solutions. Welcome to data science. In the demo, and all along this course, I focused on logs regarding AWS API calls provided by CloudTrail, but there are other AWS services which also provide out-of-the-box logging you can use, such as load balancer logs, networking logs that can be used for networking troubleshooting, S3 static web pages, access logs, content delivery network logs, AWS billing log files, and many others, all delivered into Amazon S3 for further analysis with other AWS services. If you need a dataset to start, check out the AWS datasets page. You can also build something with your own dataset. Go build something and show us what you built in the forums. We would love to see that. Now, since Amazon S3 is data agnostic, which in other words, it just means that it will store it, whatever you put inside a bucket, it is very common to create a custom data analytics solution by having systems and applications adding data into Amazon S3. We wanted to keep this introductory data analytics course short for you, but we have another 4-week course called Introduction to Designing Data Lakes in AWS that has an entire week just focused on different strategies to ingest the data into S3. You will discover that there are different data types and different methods to be used according each data type. That course, Introduction to Designing Data Lakes in AWS, also talks about data ingestion, processing, and visualization. Check the course notes for more information about data-related courses published by the AWS training and certification team. I hope you enjoyed this short course. The secret to successful learning is absorbing one step at a time, and by learning descriptive analysis, I feel you got what you need to move to the next step in your data analytics journey. How do you feel? Hey, congratulations! You've made it through to the end of the data analytics class. Good job learning about the basics of data analytics, including what are the main types of data analytics and why doing it in the cloud is a very good idea. You should also have a good understanding of the value proposition of data analytics and why, where, and how it may be present right now in everybody's lives. You continue to progress as you learned the basics of some popular AWS services used towards data analytics solutions, such as Amazon S3, Amazon Athena, and Amazon QuickSight. And you finished strong by watching a demo showing how to bundle up those AWS services together to build up a basic data analytics solutions that builds charts about API activity in an AWS account with information provided by AWS CloudTrail. I hope this inspired you to continue learning, exploring, and experimenting with data analytics, and I hope you feel encouraged by experimenting with your own data sets as well. I have definitely enjoyed bringing this content to you, and I hope you enjoyed watching as well. And I also hope to see you on the next course.